Welcome to O'Reilly Maths. This is the 2022 Leaving Cert Higher Level paper, and we're looking at question number 3. And this is on coordinate geometry of a circle. So part A says the circle C has equation x squared plus y squared minus 2x plus 8y plus k equals 0, where k is a real number. The radius of C is 5 root 3. That's the radius of the circle. Find the value of k. Okay, well, from our tables book, we have we have this bit here. Sorry, this here is taken from your tables book. So when the circle equation is given in this form, which is this one here, we know that the radius is g squared, square root of g squared plus f squared minus c, where minus g minus f is the center. Okay, so we're going to use that now. So the square root of g squared plus f squared minus c, that is the radius, okay? Okay, now c will be the constant term, so you can RC here, if I just color code this, RC there is going to be this k. And to get our g and f, we're going to compare 2gx here with minus 2x, and we're going to compare 2fy with plus 8y. So from that you can see that if 2gx is equal to minus 2x, that means 2g is minus 2, so g is minus 1. So this becomes the square root of g is minus 1, so it's minus 1 squared, plus positive 8 here is equal to 2f, so that means f is 4, so it's plus 4 squared. And then minus c, and for us c is k, so it's minus k. And it's the square root of all that, and we know that the radius given in the question is 5 root 3. So 5 root 3 is equal to this. So now we've set up an equation using this, set up an equation in k, and now all we have to do is solve that equation. Okay, so, well, we can square both sides. First of all, when you square this side, 5 root 3 by 5 root 3 is 25 by 3, which is 75. Do that in your calculator. Remembering we're squaring both sides here. Squaring this side, and then we're going to square that side. So you get 75 here. Over here, we're just going to get we will get the square root and the square will undo each other, so you've just got 1 plus 16 minus k, and then you rearrange, bring the k minus k to the left, and the 75 over here becomes minus 75, so you get 17 minus 75, which is minus 58. So there's our value for k. Okay, part B, the circle x minus 5 squared plus y plus 2 squared is equal to 20 has a tangent at the point 9 minus 4. Find the slope of this tangent. So it's always a good idea to try and visualize. You know, if you have a circle, here it is, just to sketch it out. It has a tangent at the point 9, 4, so let's imagine this is the point 9, 4, minus 4 here. It's got some tangent there at that point to the circle. And we have to find the slope of that tangent. Well, when you've got a tangent, if you draw a line from the point of contact of a tangent back to the center, first of all, that's a radius. And also, these two lines are at 90 degrees to each other, always. So that's a 90-degree angle. So their slopes are perpendicular. So if we can find the slope of the radius, then the slope of the tangent will be perpendicular to that. And with this radius, we have one point at the end, 9, comma, minus 4, and the other point will be the center of the circle. And the center of the circle, if we follow the equation that's given up here, the other equation for a circle, the center is HK, right? So the H number there, the K number there. Okay, so it's minus H minus K, and we've got minus 5 plus 2. So what that means is that our center is center of this circle is positive 5, comma, minus 2. So that's this point here, 5 minus 2. So we find the slope between 5 minus 2 and 9 minus 4. So I'm going to use the slope formula from the tables book. And the slope formula is y2 minus y1 over x2 minus x1. So I'm going to call this point here x1, y1, and this point here x2, y2. So y2 minus y1, that's minus 4 minus 2, all over x2 minus x1. x2 is 9, minus x1 is 5. And when we put this into the calculator, what do we get? We get minus 1/2. So the slope of the radius from the center to this point, 9 minus 4, this slope is minus 1/2. So a line perpendicular to that will have a slope. Remember, to get the slope of a perpendicular line, you take this fraction, flip it upside down, and change the sign. So instead of minus 1 over 2, it'll become plus 2 over 1. So the tangent slope is plus 2 over 1 or 2. And that's part B. Okay, finally, part C. Two circles, each have both the x-axis and the y-axis as tangents. And each contains the point 1 minus 8, which you can see here. So the point 1 minus 8 is on both circles. Find the equation of each of these circles. So it looks like we really have very little information here. But if you think carefully about this, the fact that the x-axis and the y-axis are tangents to both circles, what does that actually mean? Well, if we think about a line that goes out here like this, that line will go through the center of each circle. They're roughly there and there, okay? So what we know about the coordinates of these points is that whatever the radius of the big circle is, if we call the radius of the big circle or, then the coordinate of the center of the circle would be or, because it would be over or on the x, and then minus or on the y, whatever the radius is. So if the radius was 8, the center would be 8, comma, minus 8. If the radius was 10, it would be 10, comma, minus 10. So if the radius of the big circle or the small circle is or, the center would be or, comma, minus or. Okay. So the center of each circle, we can say, is or, comma, minus or. So that's a bit of information. The radius of the circle, or the circles, we can also say is or. Okay. And we also know a point on each circle. So if we think about our formula, again from the tables book, x minus h squared plus y minus k squared equals or squared. That's our formula in the tables book. If we think about these things here, well, what can we do? We do quite a bit. We can put the radius or in here. We can put the radius or in here for the center. and then we can put the minus or in here for k. So we can substitute those things in, and also what we have is we have a point on the circle. So this point here we can put in for x. So any point on the circle, you can place the x part of that point in here, and we can put this point here in for y. And by doing all these substitutions, we end up with an equation in OR. So you'll see here, this will become 1 minus OR squared plus y is minus 8 minus k. Now k is minus OR, so be careful there. It's minus k squared, and that's equal to OR squared. So this is an equation here. You can see already it's probably going to become a quadratic equation, and it's in OR, so we can go from there. Okay. Oh, sorry, I should have replaced that minus k there with minus OR, isn't it? My mistake. Not minus k, that was minus OR. Okay, so there's my substitutions, you can see. Again, just to be clear, I'll highlight them. Minus 8 went in there, the 1 went in there, minus OR went in there, and OR went in there for h. Okay, so let's now work out this equation. So this here will become 1 minus OR squared is 1 minus OR by itself. And then over here you've got minus 8, minus OR is plus OR. So that's minus 8 plus OR, or indeed OR minus 8. And again, that's squared, so you're going to be multiplying that by itself. And that's equal to OR squared. So we'll multiply this out and tidy it up. Let's see what we get. So 1 by 1 is 1. Minus 1 OR minus another 1 OR, that's minus 2 OR. Minus OR by minus OR is plus OR squared. Plus OR by OR is OR squared. Minus 8 OR minus another 8 OR is minus 16 OR. And minus 8 by minus 8 is plus 64. And that's equal to OR squared. Okay, so we're tidying this up. So what have you got? On the left, you've got OR squared plus OR squared. You bring this OR squared over, becomes a minus, so you're left with just OR squared on the left. Then you've got minus 2 OR minus 16 OR. That's minus 18 OR. And then you've got 1 and 64, which gives us 65. And that's equal to 0 because you've moved the OR squared. So now you've got a quadratic equation which you can solve. And what's this going to give us? It's going to give us two values for OR, which will be the two radii of the circles. So solving this, you can solve by formula, or you can factorize it. So there's actually factors of 65 that give you minus 18, are 5 and 13. And it's going to be minus 5 and minus 13. So that means that OR is 5 or 13. So there's my two radii for each circle. But what did they ask for? They said find the equation of each of these circles. Okay, so the equations, I'll do them up here. The first circle, the equation is going to be, it's got a radius of 5. So the equation will be x minus h, so h would be 5 squared plus y minus 5, remember, because the center is 5 minus 5 to get to here. So over 5 minus 5, 5 is the radius of the circle. So y minus 5 is actually y plus 5 squared. And that's equal to the radius squared, and our radius is 5, so 5 squared is 25. So that's the equation of the small circle. And then or is equal to 13. The other equation then is x minus 13. Because remember the radius of the big circle is 13, so the coordinate of the center will be over 13 minus 13. So 13 minus 13 is the center of this circle. So it's x minus 13 squared plus y minus minus 13, which is plus 13 squared, is equal to 13 by 13, which is 16913 squared. So there's the two equations for the two circles, and that's the end of the question.